Hello everybody, Sir Beaton here, and welcome back to another mathematics video. In this video, we will be looking at the relation functions and graph, some past paper questions on this topic. So let's get straight into the video. So the first question says, the incomplete table below shows values of x and y for the function y is equal to 2 raised to the x power. So 2 raised to the x power. For integer values of x from -1 all the way to 4. So we have the table here showing what is going on at the top. We have x, and these are all the values of x. And we have y. These are the values of y we get after we work out this here. So the first one says, complete the table for the function y equal 2 raised to the x power. So we see here, we have the first value of x, which is -1. So we know the function is y is equal to 2 raised to the x power. So we see the first one, x has a value of -1. So this will be y is equal to 2 raised to the -1 power. And hence this will be equal to y is equal to, so this is raised to the -1 power. This will become 1 over 2 raised to the first power, which is the same as 2. Since y will be equal to 0.5. So here we can say 0.5. And the next one, 0, that is already filled out. So next we have x has a value of 1. So this is y is equal to 2 raised to the x power. In this case, x is 1. So y will be equal to 2. So this here is 2. Next one, we have y is equal to 2 raised to the x power. In this case, x is 2. So this will be y raised to the second power. Hence, y will be equal to 2 times 2 will give you 4. So this here has a value of 4. And this is already filled out. And last but not least, we have y is equal to 2 raised to the x power. In this case, x is 4. So this will be 2 raised to the 4th power. Hence, y will be equal to 2 raised to the 4th power will be 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So y is equal to 16. So here would be 16. And there we have our 2 marks by just substituting values for x. So the next question says, on the grid provided on page 27, well, page 27 will be the next page, draw the graph of y is equal to 2 raised to the x power using the scale of 2 cm to represent 1 unit on the x-axis and 1 cm to represent 1 unit on the y-axis. And this is an easy 4 marks. So let's represent this graph, y raised to the second power. So the beauty about this mark, these 4 marks here is that we already have the coordinates. So all we need to do is plot these coordinates on the graph. But also they give us a scale, so we must follow this scale to the T to get all of the marks. So the first things first, let's represent the scale. So it says 2 cm to represent 1 unit on the x-axis. So for every 2 cm, we know this is 1 cm. Here it will be 2 cm. So this will represent 1 unit. So this will be 1. So we skip 2 again. Here it would be 2. Here would be 3. And here would be 4. And here would be 5. And then we skip again. Here it would be -1. Here it would be -2. So that is on the x-axis. And the next one says 1 cm to represent 1 unit on the y-axis. So on the y-axis, which is here, 1 cm would be here. So this will represent 1 unit. So we just count it in 1. So this would be 2. Here would be 3. Here would be 4, 5, 6, 7, 8, 9, 10, 11. So now it's just for us to plot the points. So the first set of points we have would be -1, 0.5. So -1, 0.5. So we go -1 on the x-axis and we go up 0.5 times. So if here is here, so 0.5 would be somewhere like 0.5 would be somewhere like there. And the next point we have would be 0, 1. So this would be 0, 1. So we go 0 across, 1 up. So that'll be right here. The next point we have is 1, 2. So we go 1 across and 2 up. So that'll be right here. Next point would be 2 across, 4 up. So 2, 4. So we go 2 across and 4 up. So 2 across, 4 up. That will be right here. And the next one would be 3 across, 8 up, which would be right here. So we go 3 across and 8 up. So 8 is right here. And I see we have to add in a few more. So this would be 12, 13, 14, 15, 16, 17. And last but not least, we have 4, 16. So this will go 4 across and 16 up. And there we have our graph. Now it's just for us to connect the points. And there we have our graph of the function y is equal to 2 raised to the x power. So to graph any function, all we need to do is you can create a table of values, substitute suitable values for x, and you just get the coordinates and you plot the points. And then you just connect the points and that will give you the graph. And the next question says, the function f with domain a being equal to 1, 2, 3 is given by f of x is equal to half x minus 3. What is the value of f of 1? And this is going for 1 mark. So there's a reason why this is going for 1 mark, because it's very simple. So f of 1, so we know f of x first of all is equal to half x minus 3. So we know f of 1 would simply be half multiplied by x, which is 1. So we just replacing x with the 1 here, subtract 3. So half of 1 would simply be 0.5 minus 3. So 0.5 minus 3 would simply give us negative 2.5. So f of 1 is equal to negative 2.5. And that is the answer for that one easy mark. The next one says, the function f with domain, well, the same function, and you're asking us to find the value of x for which f of x is equal to negative 2. So you want to be careful with these kind of questions. Many persons would go and they would substitute 2 inside of this function, but they did not say find f of negative 2. They said f of x is equal to negative 2. So what we will do, we will replace f of x with negative 2. So instead of, we'll write back f of x is equal to half x minus 3. Instead of f of x, we'll replace it with negative 2, because they said f of x is equal to negative 2. So this will be negative 2 is equal to half x minus 3. Now they want us to find the value of x, so we just solve like a normal equation. So this will be, this 3 is subtracted, we take the will add. So you'll have negative 2 plus 3 is equal to, now half x is the same as x over 2, right? Half x is the same as x over 2. So we can just rewrite that as x over 2. As 1 times x will give you x divided by 2. So negative 2 plus 3 would be a positive 1 is equal to x over 2. So this 2 is divided, we take 2 will multiply, so we'll have 2 multiplied by 1 will be 2, so x is equal to 2. So you can therefore say x is equal to 2. And that is the answer for x when f of x is equal to negative 2. So the next question says, an ordered pair for the function is expressed in the form a, comma b, using your answers to a1 and a2, or otherwise, list the ordered pairs for the function. So they want us to use the answers here and here. So first of all, we see the ordered pair for here would be, we see x has a value of 1, and you see this will give us a value of, when we replace this, negative 2.5. So this negative 2.5 would be the y value, and this 1 that we replace x with will be the x value. So this will be 1, negative 2.5. So that is the first function I can take. So the ordered pair for the first will be 1, negative 2.5. So we see in this one, we see f of x has a value of -2. So we can say this f of x is the same as y. So we can say y has a value of -2 and x has a value of +2. So the coordinates here would be, the first one would be xy. So it's 2, -2. You always put the x value first. So the other ordered pair would be 2, -2. And that would be the ordered pairs for this function. So this would be the first 2 ordered pairs. So we want the other one. Remember, we're dealing with 1, 2, and then we also have another x value here, which is 3. So we need to substitute 3 inside of this function to get the third one. So we know the function is f of x is equal to half x minus 3. So we already have this is from 1, this is from 2. So now we have to find when x is equal to 3. So we can say f of x, instead of x now we'll say f of 3 is equal to half of 3 minus 3. So half of 3 would simply be 1.5 minus 3. This will give us a -1.5. So we see the pair here would be 3, -1.5. So the last set of ordered pair would be 3, -1.5. And the last question says, explain why f of x cannot be equal to 5 for the function. So let's see, f of x, we want to explain why f of x cannot be equal to 5. So we see the function is f of x is equal to half x minus 3. So let's see why it cannot be equal to 5. So let's replace f of x with 5 and see what we'll get. So we say 5 is equal to half x minus 3. So if we work this out, we'll have this 3 is subtracted, we take it over, add, so we'll have 5 plus 3 is equal to half x. So 5 plus 3 is 8 is equal to, so half x is the same as x over 2. So this 2 is divided, and when we take it over, multiplies, we'll have 16 times 2. So we'll have 8 times 2, which will be 16 is equal to x. X is equal to 16. So because x is equal to 16, if we go back to the domain that they gave us, you see this function has a domain from 1 to 3. So we can say 16 is not in the domain, which is 1, 2, 3. So you can say 16 is not in the domain, which is 1, 2, 3. So therefore, f of x cannot be equal to 5 because the value of x will be 16 and 16 is not in this domain, which is from 1 to 3. And that is why the function f of x cannot be equal to 5. And with that, this has brought me to the end of this video. Remember to keep practicing. Practice makes perfect. And I will see you in the next video in which I will look at some additional questions. Until then, keep practicing and take care. See you in the next one.